Hello, everyone, and welcome back to the inaugural Capstone Showcase. I am very excited to introduce Ralph Bernardo. His presentation is our final one for today. He is a master's candidate in our developmental psychology track. I will tell you all about my wonderful experience working with Ralph and why I'm really going to miss him now that he's graduating. Ralph, just as a forewarning, I asked the students to ask you about recruitment. So you'll get a question about recruitment. And as a reminder, students, please ask him, 698 students, please ask him about recruitment. So the title of Ralph's presentation is Mathematical Equivalence in College Students. And Ralph, go ahead.
Welcome to my presentation, Investigating Mathematical Equivalence in College Students. Since this is a presentation about mathematics, it feels appropriate to start off with an equation. What I'd like to know in words is what you can tell me about this equation. You probably will say that it states that 10 plus x equals 10 times x. However, if your first response is something different, then you'd be more aligned with what some college students think. Just gonna make one quick adjustment. There we go. A college professor gave this equation to his first and second year college students, and over 50% of them said that the right side was larger because it involves multiplication instead of addition. So it was reading about this response that sparked my interest in investigating fundamental conceptions about mathematics, those things that you start learning when you are quite young and perhaps even take for granted today. When a college student says that the right side of this equation is larger because it involves multiplication instead of addition, that involves their thinking about the equal sign. It means that instead of seeing the equal sign as a relation of equivalence, seeing that both sides of this equation are the same, some college students are focused on just the operations of addition versus multiplication and ignore the meaning of the equal sign. So why am I so interested in the equal sign? Well, being able to understand the equal sign is a super important idea in mathematics. I like to think of equivalence as granting us mere mortals access to the infinite, in which we have the ability to determine if countless varying forms are the same. Here's an example using fractions, which is a math topic that a lot of youngsters struggle with when they first encounter them. As you can see, it's an important skill to be able to take a form that looks complicated and to be able to simplify it so that it's more understandable. However, I have a more practical reason for my interest in equivalence. In the last pre-pandemic national assessment of American students, 40% of 12th grade students did not achieve the basic math competence level, and another 35% just achieved that basic level, which means that 75% of American students are graduating high school without having achieved mathematical proficiency, which perhaps helps to explain why in a college math class, half the students made an incorrect claim about the equal sign. Researchers have long been interested in how children think about the equal sign. In a study going back to 1932 from Renwick, it was stated that young students tend to think of the equal sign as a command to perform an operation. In the 1970s, Baer and colleagues coined this great phrase, do something signal, which many math cognition researchers have referenced. Baer and colleagues documented that young students prefer equations in the problem equals answer format, in which you're asked to figure out what is presented on the right side of equation. Young students really disliked equations presented outside of that format, in which the unknown was presented on the right side, as well as these identity statements like 3 equals 3. Young students would modify them to 3 plus 0 equals 3, because they felt you had to do something with the math, rather than just think about how numbers relate to each other. So Baer and colleagues asserted that young students tend to think about the equal sign in an operational rather than a relational way, which has been confirmed by several decades of research thereafter. Many researchers using these two constructs have proven that young students really prefer the operational understanding and have trouble with the relational viewpoints. But what's relevant to my research is how long these operational understandings persist and their presence in young adults. Fife and colleagues did a formal study with college students in developmental math classes regarding equivalence that was more rigorous than that survey about the equation I introduced at the beginning of my presentation. And they found that 62% of college students displayed a relational equivalence understanding. But strikingly, 16%, 1 in 6, preferred the operational understanding, which I find to be an incredible result, given the number of years from kindergarten to the 12th grade that students spend learning math. For clarification, the 22% non-relational is when responses did not fit into either the relational or operational constructs, which is a decent amount of their sample, and also motivated my research into thinking about how researchers are operationalizing our conceptions about the equal sign. However, that's not to say that this relational equivalence construct is not important. Relational equivalence has been correlated or implicated as significant for math performance with students in various stages of their mathematics education, during elementary school, middle school, high school, and even with college students. Although it's important to note that there isn't a lot of research that has been done with college students specifically regarding the equal sign, which was a huge motivation for my research. So going back to this dichotomy of thinking, the binary operational relational paradigm that Baer and colleagues created, I think that created a sort of groupthink in this research community, and that researchers were sort of locked into their thinking about the equal sign. Interestingly, even in the study that Baer and colleagues did in the 1970s, these researchers did something I haven't seen many researchers do, was to connect how these equivalence constructs of operation and relation compare to how equivalence is formally defined in mathematics. Baer and colleagues touched upon this idea, but they didn't follow through with it for the constructs that were defined and that many researchers ended up using for decades. Formally in mathematics, to use the equal sign, the relationship must be reflexive, symmetric, and transitive. So reflexive is just an identity. It means that when you're talking about the number 3, it means something unique and distinct, no matter what that quantity describes. And we need to have unique and distinct numbers. Otherwise, our whole sense of anything we could do with mathematics would completely fall apart. Symmetric is probably what comes to mind with most people think about the equal sign. That is whether or not two things are the same. And transitive, which allows the idea of substituting things that are equal for each other. In this case, your first thing is called A, and it's equal to your second thing called B. And then you notice that your second thing called B is equal to the third thing called C. So of course, you now realize that your first thing was always equal to your third thing was always equal to your first thing. What I noticed in the research literature is that for the construct for relational equivalence is that researchers really focused just on sameness and really didn't think about substitution so much. So eventually researchers realized that relational equivalence, exactly what that is, needed to be better defined. Riddle, Johnson, and colleagues about a decade ago created 4 tiers of equivalence understandings, which they called the construct map for equivalence. The first tier is purely operational, in which students don't have any sense of a relational format and can only solve questions in the problem equals answer format. The second tier is flexible operational, in which students start to be okay with non-canonical forms, those outside of the problem equals answer format. So this tier implies that students have some awareness of the symmetric property of equivalence, and researchers also realize that students aren't freaked out by reflexive statements in this tier. At the basic relational tier, the third tier, students can manipulate both sides of an equation to solve for an unknown, which implies recognition of symmetry. And the fourth tier is a more complex form of the previous tier called comparative relational, in which students can solve for multiple instances of an unknown and perform more complex manipulations of equations. So while I think this construct map is better capturing how equivalence knowledge develops, rather than having some switch between operational and relational understandings, I believe it still lacks an important conception about equivalence. That important conception is what was defined as substitutive equivalence by Jones a few years before the construct map was created. Here we are discussing the transitive property of equivalence, which is different than the reflexive and symmetric properties. And the simple algebra problem, I hope, makes that formal mathematical definition I presented 2 slides ago more concrete, I think, for most people. And just to reinforce my take on the research literature, the majority of equivalence research has focused on sameness as the core feature of relational understanding and does not incorporate any notion of substitution. Jones came to this conclusion about substitution by using specifically designed software to test equivalence conceptions in students. And here, what I'm displaying is how his software actually looked and worked. A student is presented with an expression where the goal is to simplify to one number and giving a list of options to substitute. So here you can see the act of substituting an expression, a correct one. However, note that there is an incorrect equation in the available options. Since Jones placed incorrect equations in the available options, that led him to believe that sameness and substitution are distinct conceptions of equivalence because students would substitute expressions that did not contain sameness. And so now let's discuss my project. Given that college students have not been comprehensively examined for their full range of equivalence understandings, and considering that a methodology for investigating substitutive equivalence has been devised, my study looked at how these 3 distinct equivalence understandings, operation, sameness, and substitution, impacted the mathematical performance of college students. Based on my review of the research literature, I hypothesized that all equivalence understandings, operation, sameness, and substitution, and note that these are the only distinct notions of equivalence that I found were operationalized in the research literature, that these 3 considered in combination with college students would have a significant effect on their mathematics test-taking performance. From a cognitive standpoint, it makes sense that a student could have 1, 2, or all 3 of these notions in mind when they solve a math problem. So taken together, they should be significant in how they influence math performance. The next 3 hypotheses are looking at each equivalence conception in isolation. Substitutive equivalence understandings in college students should have a significant effect on their math performance. Sameness equivalence understandings in college students should also be significant. Operational equivalence understandings should not have a significant effect on their math performance. And for this last hypothesis, I'm considering what I thought was the most important equivalence conception. Substitutive equivalence understandings in college students will have the greatest influence on their math achievement as compared to operational and sameness equivalence understandings. So I recruited 91 participants from online communities geared towards college students, Discord, Facebook, Reddit, Twitter, and through survey exchange platforms. I came to that number based on a power analysis I did before recruitment that determined I needed 90 participants based on the specific statistical analysis I intended to use and the desire to detect a medium effect. Most of the recruits came through Reddit and Discord. I'm really glad that I thought about Discord. It wasn't a place I thought of initially, since it started out as a platform to discuss video games, but it actually has a huge component to it to discuss educational related topics, which makes sense since lots of college students play video games. All of my participants identified as current undergraduate students, and I'm pretty happy about the age rate that I achieved, as I wanted students who were not too far off from their high school years, because I'm looking at what I think is the tail end of a long process of developing equivalence knowledge. And I didn't want confounds from people who were too far removed from the educational system. I'm also happy that the majority of my participants received their primary and secondary education in the US, because there are differences how equivalence is taught across the world, which would of course confound my results. So I created and administered a survey online using Qualtrics, which is software I never used before, but I really like learning new software, and I think Qualtrics is really, really good. It helped me immensely to manage my project. Anyway, I used 2 measures that have been validated and are reliable. The mathematical equivalence measure for equivalence understandings and the mathematical performance measure for math achievement. The mathematical equivalence measure has two parts. Here's an excerpt of the first part. A student gets 12 statements about equivalence to rate, where very clever is 2 points, sort of clever is 1, and no points for not so clever. So here's an example of an operational statement. And here's an example of a sameness statement. And here's an example of a substitutive statement. This item also contained control statements, which were not equivalence definitions, just to make sure that the participants were really rating the statements. To help explain this part of the equivalence measure, I'm going to show some results. So you can see all 12 statements the item had. The theoretical min and max was 0 to 2. As you can see, the control statements were the lowest, which is good. It helps to confirm that participants were taking the measure seriously. And substitutive and sameness statements are rated as more clever than operational statements, which is what you would expect from college students. The second part of the equivalence measure asked students to rate what they thought was the best definition of equivalence, which could add 1 point to either their operational, sameness, or substitutive score, and no points for a control statement. Fortunately, I didn't have a lot of people picking control statements. I think there were only 2 out of 91. The idea for this part of the measure was to see what particular conception of equivalence, operation, sameness, or substitution that each student preferred, and to account for that when their equivalence score was created. So here you can see the results for that item. And interestingly, the overwhelming preference, 73%, picked a sameness statement, which I think tells us a lot about how students primarily think about equivalence. So here's an excerpt from the mathematical performance measure. It starts with with simpler problems involving arithmetic, and it gets more complex with algebra as you proceed through it. It becomes more conceptual by the end, and it generates a math performance score. So here are the descriptive statistics for my measured variables. For the equivalence conception, sameness was the highest, followed by substitution, both of which were markedly higher than operation, which is what you expect for college students, that they consider on average operation as less clever. They also did on average pretty well in exam. So I hope the exam wasn't too taxing on them, because I know that not every student is a big fan of math. So let's discuss what I did with the variables. The 3 equivalence understanding scores, operation, sameness, and substitution from the equivalence measure were considered as predictor variables. And the total mathematical performance score from the performance measure was the outcome variable. This analysis was sensible as a multiple regression because each distinct equivalence conception contributes uniquely to math performance. And these three equivalence understandings can be held simultaneously. So here are my results from the regression analysis, which I will first relate to my hypotheses, and later I'll provide a visualization for. So how did my results match up with my hypotheses? All equivalence understandings considered in combination, operation, sameness, and substitution in college students had a significant effect on their math performance. Substitutive equivalence in college students had a significant effect on their math performance. These results for high school students agreed with results that were found in, these results for college students agreed with what was found for high school students. Sameness equivalence in college students had no significant effect on their math performance. Operational equivalence in college students did have a significant effect on their performance. And operational equivalent in college students had the greatest influence on their math achievement as compared to sameness and substitution. These results for college students disagreed with the results that had been previously found with high school students. I think the same result is different from high school students because by the time a student is entering college, favoring a sameness conception doesn't have as much value as it did in high school. This is in contrast to the substitutive conception, which had value in high school and continues to have value when students are in college. I find the operational result to be really fascinating and why substitution does not have the most value for college students. While substitution is a significant positive influence, of greater importance is the significant negative effect that operation has. In other words, favoring operational conceptions have a greater disadvantage for college students for their performance than their gain is from preferring substitution. So what this really says is by the time you get to college, you really should have embraced a relational nature for the equal sign. And if you haven't, by then you probably will have a lot of difficulty with your math courses. This graph helps to summarize my results and illustrate the impact of each distinct equivalence conception in which substitution had a significant positive influence. Sameness was non-significant, relatively neutral influence, and operation was a significant negative influence. Another notable result was my adjusted R² value, which takes into account the size of your sample to provide a better estimate for your variance. Mine was 0.188, which means that roughly 20% of the variance in math performance, 1/5 of it can be explained by equivalence conceptions. Considering all the variables that could go into a student's math performance, I think that this 20% that I found really speaks to the importance of equivalence knowledge. Notably, I found a significant large effects for operation substitution by looking at their beta values. And again, here I'm showing that the negative operation effect was greater than the positive substituted one. So some contributions my research has made to the body of knowledge for this topic is that it extends the finding that substitutive equivalence has a significant effect on math performance from high school to college students. It generalizes the finding that operational equivalence is detrimental to math performance, not only for students in developmental classes, but for a broader population of college students. If there's further support for this distinction between sameness and substitution equivalence, and it suggests potential revisions for the widely used construct map for equivalence. Here are my limitations. I was only investigating existing relationships between equivalence understandings and math performance. I wasn't conducting a controlled experiment. I didn't review the participants' math work, which could have provided greater insight into their equivalence understandings. I only asked arithmetic and algebra questions. Results might differ for other branches of mathematics, although I don't really think they would because equivalence is such a central concept. But if they did, that would be really interesting. The final points I'd like to make, we can call this the why is my research important section, is that math is really everywhere in our lives today. Perhaps no greater evidence is the pocket computer we all carry around nowadays, which runs on math, and it impacts your behavior in countless ways. I find it really important to mention that even after controlling for significant socioeconomic factors, mathematics achievement is strongly correlated with whether you go to college and even complete a college degree. And we live in a society now where a college education dramatically impacts your lifetime earnings. So I think calling mathematics education a gatekeeper, I think forces us to consider just how powerful a role mathematics has in society. I'd be remiss if I didn't mention the latest post-pandemic national assessment results, which saw the largest drops between math assessments for 4th and 8th graders since the national assessment began in 1990. A lot of people are concerned about this, and perhaps my research can contribute to the dialogue in terms of providing quick assessments of mathematical ability and helping educators in terms of what to focus on. Going back to the idea of mathematics education as a gatekeeper and about the current state of it, math is a social force that could either provide or restrict access to what you do with your life. And so I feel you can make the argument that the more you can achieve with your mathematics learning, the more you can do in terms of increasing your range of opportunities. So I just put up my references just in case anyone had a particular reference they wanted info for. Thanks everyone for your attention and time. Thank you, Dr. Alicia, for all your help, for all the professors I had through various classes, to Dr. Marquez Lewis and Nakia Isaac. And I'll put up my email there in case you have questions later, but I really look forward to taking your questions.
Thank you so much, Ralph. And please put your questions in the chat. I will try to cover a few topics that I know some of you may be interested in. But I want to start off, Ralph, just by asking you a question about why you decide. So you and I, when we were working on this project, and you had this idea from the start, pretty much. Actually, you started talking to me about this idea in 675, the semester before. I said, that's a great capstone idea. So hold on to it for next semester. And you came into the capstone right away, said, this is, more or less what I want to do. And I said to you, are you sure about giving a math test trying to recruit people on the basis of you're going to take a math test to help me with my research, and no, I'm not paying you for it. So how exactly, tell me what it was like working through that, and whether, you had any second thoughts, and why you were so committed to this topic.
My commitment to it was just based on my interest in math. Throughout, doing the program at SPS, I've been math tutoring, so I've been kind of like immersed in math, and it's just something that, I've always been passionate about it. I've loved math since I was a kid, and in terms of like conducting the research and like connecting into the idea of like how it impacts just people's lives, that was really the foundation, in terms of like their potential. That was kind of the motivation for wanting to stick to it. I guess in terms of like the specific question of like employing a math test, we were required to use previous validated measures. So I used one that, I thought was, fit the criteria of like reliable and validated, but also I thought was simple to deliver online, and I thought wouldn't take a lot of time. My actual concern was that the test I previously used was used with high school students. And so, I was like, oh man, is this going to be too easy for college students? And honestly, you saw some of the questions. Anyone who has done okay with high school math courses would do just fine on this test probably. But I remember you had, and I definitely agree with you. You had said that basically, if you make it too complicated, you could really lose people, and you may not have people completing it, and a goal I had was to have complete data. I noticed that I think on that part, I actually didn't seem to lose too many people. So like once people actually started doing it, they did finish it. I did have tons of people who didn't complete my survey, but I only used that 91 represents people who completed the whole survey. Maybe 50% of people who tried it completed it. But throughout I guess as once I finally did it and I saw like what the results were, I guess I was feeling pretty good that I did keep it simple and not make it overly complicated, because I felt like that seriously could have hurt the recruitment process.
Thank you. So we have a question from Michael Hall. Was it a challenge to find existing research on this topic? How did you go about it?
This, in terms of like the equal sign, that's something that's been studied for a super long time. What was hard was kind of finding a niche, in terms of like, what can I contribute to it? What can I say about it? And, it was this whole idea of like this substitutive equivalence that was relatively newer, and a minority of researchers in the community were talking about it. That's what got me sort of on that aspect of it. I would say, but I spent a lot of time researching when I was in 698. I actually had to stop myself from researching, because I wanted to keep researching. I could, because, like one thing I find is that, particularly like when you're using the digital library you have, is that you can easily get the previous, like what's cited in the paper or what papers have cited it. And that can just take you on an endless chain of researching, when you're researching, I guess, any body of knowledge. But I find it immensely useful though, because you can kind of look at someone's flow, in terms of, what they're contributing to. I guess what helped me to identify, like the niches too, was when, looking at how many people cited a particular paper, I could say, oh, okay, this topic doesn't seem like it's getting enough attention. and is that something maybe I want to look at? Do you want me to look at the chats too to answer questions, or?
I can ask
Okay,
you the questions.
did I
I just
answer
prefer,
every aspect of your question there?
so, Michael, I hope you got an answer to your question. And send us a follow-up if you need more of an explanation. So your next question comes from Heather Zeman.
Okay.
So Heather Zeman and her team have done a fantastic job all day today supporting the psychology program. And they supported us all semester long with all of our programming. So thank you. If we haven't, I know Dr. Marquez Lewis will absolutely be thanking you, but for my part, I want to thank you on behalf of all of our students because you've done a wonderful job with us this term. So the question is, we know that some folks consider themselves as not good at math, yet your research really underlines the idea of math as a gatekeeper. Did you experience, scrolling down, did you experience resistance from people to taking the test?
I mean, the only thing I have to go by is the information I have in Qualtrics, which will record everyone who makes an attempt. And so if I look at that, maybe only 50% of people actually completed my survey. That seems like pretty high resistance. Someone saying, "Oh man, I guess that," I feel like that's the kind of thing that you could see when you deliver something in person. Because like online, I can't visibly see people's reactions as they're taking the test. I mean, the average time for taking it was 11 minutes. So I feel like that meant that I feel like most people just kind of dived into it and completed it. I think if the average time was much higher, then I think I would think that there was a lot more resistance to it. But it was such a simple test, honestly, in terms of just like taxing someone's math ability, that I really hope that there wasn't that much resistance. But I mean, one thing with Dr. Alicia tried to kept me thinking about the whole project is that I might think this is the most interesting thing in the world, but that you're trying to sell it to a general population of people, and there are some people who are just going to see math and be like, no way. So I'm happy that I had no idea how the recruitment was going to go, if I was going to be able to get the number I wanted. And I was I'd say I was very aggressively recruiting, like I was really like trying to hit as many different communities as I could, to make that number. So yeah, hopefully that answers your question.
So next question comes from Casey Connolly, and that is, did you find any differences between genders regarding how the participants viewed equivalence? Also, when collecting data, did you ask participants to self-report their ACT or SAT math scores?
Yeah, I didn't ask that, and that's actually that I probably should have done something like that, because then it would give me a sense of how good perhaps the people are at math going into the test. I mean, one thing I don't really have a sense of is what somebody's prior math achievement was. I didn't really find any differences among gender or any other samples, I mean, or subsamples. I mean, one thing I would have liked to do is look at a difference between 2-year and 4-year college students, but I didn't have enough 2-year college students to really conduct that analysis. But yeah, I kind of, with regression analysis though, that your sample size is really important. Like if you have a much smaller number, it's going to dramatically impact your results. And so, I feel like if I was to do this a study again, and if I wanted to dive into those like subgroups, I think I would want a much larger sample to begin with, just so that I'd have enough for the regression to make sense.
Absolutely. So next question from Augusto Mata. Congratulations, your presentation was very engaging and you made it easy to understand, even though it is a complex topic. Did you find any correlation between math proficiency and any demographic information collected?
I didn't, but in some cases I didn't have enough of a particular demographic, I think, to conduct a proper analysis. But I didn't really. Oh, okay, yeah, I didn't really detect any differences in subgroups.
Okay. So could you tell the audience a little bit about your process for recruitment? Because a lot of questions have been regarding, your sample composition, demographic characteristics of your sample, and you used a tool that I haven't had students use before, which is Discord. And also at one point you said to me, I had 200 people start to take my survey, and I was just like, wow, this is amazing. So tell us,
Um,
about your
yeah, I
process.
mean, it's so Discord is it's like it's broken in like basically it's basically a bunch of communities that you can based around they all center on a various so for me what I had to do is I thought about where can I find college students and so it was like things related to education but a lot of these like groups are unofficial because I mean like one of the things I know like you have to be careful about obtaining like official approval, I think, for various college and universities. But a lot of the Discord things are student run. And so, basically my process was, identify, I kind of went by numbers on it. Like you can get a sense, like there are various websites that tell you the largest communities online, largest Discords. Like you can get a global list of largest college and university discords and then the process would be like well is this somebody I can communicate with because they all have rules when you first join to say what they allow. Some don't allow surveys at all right off the bat, so like there's no point in asking people who are telling you we don't accept surveys. But I would always ask for permission. I would join and I'd ask for permission, and sometimes it could take days for people to get back to me. And I did a lot of groups. I would do, I don't know, I'm trying to think about how many communities I would try to hit every day. Initially, it was a lot. Basically, it could be like as many as possible throughout the day. I mean, the total number of groups I contacted, if among, I think, well, just Discord and Reddit, well, I don't know, it was in the hundreds probably. So like there's also like study groups, those ones I hit ask for. But the key I found was always permission, because otherwise, like if the moderators don't like you, they're gonna take down your post and you're not gonna get anywhere. But you ask permission, you wait for a response, and then if they say okay, you post it, and you just make sure that it falls within the whatever rules and regulations of the institution, that like in our case, we weren't, I think, cleared to like if it was some official thing where the college, it had to be cleared by the host college. So I had to find ones that were student run, but there were plenty of those because I think particularly with Discord, this is not something even universities and colleges are hip to. Like I think students kind of started doing this themselves. And I don't even like, I know some colleges are aware of it, but some aren't. And so because my goal was I was looking for college students. That was what my hope was. And that's where I think that was probably the greatest in terms of because like Facebook, everybody uses Facebook. It's so broad, and I didn't really spend a lot of time on Facebook. um and with Reddit, I did the same kind of approach to Discord, but I really focused on Discord, you know, just because it's, you can communicate with with the moderators, you can get their approval, they'll ask you questions, you can answer them. So yeah, it's basically it's a bunch of online groups. That's the best way to that have uh I think they have video chatting features, but I didn't do that, like text chatting features. I guess it's the equivalent of, like, I think back in the day, like Usenet groups, I guess maybe that would be, if you're as old as I am, where you remember those things. But it's with a fancy, like, really cool, slick, nice software to use.
Okay, so our next question is from Dr. Marquez Lewis. Did you consider a qualitative component to the project?
Yeah, I did, but then I felt like it'd be too hard to kind of go. The qualitative component would be, and I guess I'd have to have the technology to do it, where I could have students show their work, and then I could, because, like, to me, I could say that, somebody, based on whether or not okay, so this person is high in substitution but low in operation. But I feel like actually seeing their work, I could really validate that claim a lot better because I would see sort of how they're solving the problem. So if I was to do this again, I think that that would be, and maybe it's best to do it in person, where you actually, you try to correlate the actual student work with the equivalence conception measures that I get from each student.
So you have a question from Leticia Garcia, and the question really relates to the idea of doing this research with different ethnic groups, gender, and cultural groups. And I wanted you to, talk a little bit more in addressing this point about the issue of why you wanted primarily an American or North American sample.
Oh yeah, so equivalence is from even young ages is taught very differently in various parts of the world. And so I feel like that's why I asked the question about previous education, because I feel like that could have a dramatic impact on just mathematical ability. I don't know, can I maybe show us if I still have a slide up here? Sorry to go back like this, but it goes back to very basic stuff. Like when kids first look at equations, sorry to like keep flipping like this. I probably should just slide, but I feel like I'm almost there. There we go. This sort of like, where you're exposed to seeing equations that aren't just like 1 + 1 = 3, like problem equals answer format. In other countries, kids start doing these type of questions like right away. Where in America, it seems like I think this is one of the reasons the operational understanding gets entrenched, is that students, most of the stuff they see in textbooks are, problem on the left side, fill in your answer on the right. And it's shocking that that has such amount of influence, but it does from what and there are people who have studied this and found. So, like I know like some studies I looked at were particularly between like China and US. And in China, their education system exposes them to non-canonical forms. Canonical, I mean, just not that standard equals problem format at very early ages, and their preschool or kindergarten equivalent education, it's much more conceptual than what we have in America. So that's why I felt like, maybe it's because I'm American. That's what I was most interested in, and I've worked with American students. But that's why I specifically, and my sample was, from what I know, 2/3, I guess, had their primary education, their previous education in the U.S. So, whoops, I think my thing is going down here. But yeah, if that there's different, and people have been looking at this kind of stuff for decades, and like I think there's a famous math curriculum called like the Singapore, I forget what it is, Singapore, I forget the exact term, but I know Singapore has a math curriculum that even the UK has adopted, because I think they felt that like it was really effective, and so other countries have decided to, I don't know how much this goes on in the US, but I've read about other nations adopting the styles that countries with high performing math students have used.
Yeah, we don't do that as much, but for a number of reasons. So we have another question from Dr. Marquez Lewis. So for educators that want to increase college attendance and graduation success, what does this work suggest we should be doing, thinking about? And could you, there we go, question.
There, in terms of, maybe this applies sort of, so the question is to just increase college attendance and graduation success. I think in terms of just, increasing the success, like the completion rates, I feel that maybe it's just having and giving students the support they need. So everyone enters college from various places with various preparation. And I guess what I found is that this is a way to find, like, if students are high in this operational equivalence, maybe they haven't been adequately prepared in the mathematics for what's expected of them in college. But the question is, so once they're there in college, what do you do? And I feel like the only thing you can really do is just support people with, availability to tutoring, even high impact tutoring. I mean, I know that's something, that I know people have looked at in terms in the classroom, in like middle school and high school. I know that there's been various studies that have found that type of effective. I don't see why it couldn't continue in college for people who needed it, just to kind of get up to speed with maybe what they missed in their previous learning. Across the board, I feel like the thing that to teach people, and I don't want to make a blanket statement about education, but it's just like, conceptual work and critical thinking and focus, like math. To me, math is understanding. That's what it is. Like, I've heard people, like, I worked with a math professor over the summer who he would tell me that what he loved about math is that you don't have to memorize anything, because he also too hated memorizing stuff. Like, he's like, I hated in school if I was supposed to like memorize something out of a history book and then write a report on it. Like, when you really understand something, you don't have to memorize anything. And so specifically with math, you have to get kids off the idea that you're memorizing procedures and you're just executing procedures. It's all about understanding from day one. When you understand it, that's what math is. That's the essence of it. And so maybe that's what my research has shown too, is that, if you're looking at things in a substitutive way, that's more of a conceptual understanding than just the operational way, which clearly is a procedural way of doing something. But yeah, that's certainly a difficult problem that I know a lot of people are looking at. And I guess I just have one little small piece that I can contribute to that dialogue.
Thank you, Ralph. So I'm now going to ask you to contribute a little small piece to, the process that our current students in 698 are going through, and share with them some of the insights you've gained over the past 2 semesters, and any tips you have for greater success during the capstone.
Do things early for sure. Because it's, you don't really know how long certain aspects are going to take. Like, I found, honestly, the hardest part of it for me was in terms of the final writing of the project, was the literature review. Just because just sifting through, I guess it depends on your topic, but just sifting through like all the research that's out there and deciding what you want to focus on. I know you're given a lot of time to do it, and then there's also a lot of time to like revise it for 699, but don't like, it's almost like if you don't have enough time to work on that part, it has like a ripple effect where I feel like it's going to affect the rest of your project. So, dive into, like, I was doing research like daily and like reading research daily. It's like get yourself immersed in it as much as possible. Because you also too, like, kind of don't know where the great ideas are going to come from, in terms of what's going to be more helpful. I know, my topic I thought was pretty big in terms of what I found, but I'm sure there are people doing topics where there's even way more research to look at, and I guess, my advice would be just, don't, like, get started early and make it like a daily obligation, where you're thinking about it or like immersed in it. And also, of course, the other thing that's huge, and this is huge, I think, for any student, pick something that you're super interested in. Because if you're not like super interested, these two classes are a lot of work. If you're not super interested in it, you're not going to be motivated to work on it. So between, treat it like a job. I just saw a comment there. Yeah, you really have to say to yourself, like, a certain amount of, I understand like some students maybe can't work on it every day, but you have to have a time commitment to it. Because I feel like without that time commitment, there's just no way to like get it done and to really explore, everything that you possibly could explore. Um, I feel like you want to get to the point that you want to feel like you've exhausted everything, but I, like for me, I don't even know if I can honestly say that, because there could be something that I just didn't find with all the research I did, even though I did a ton of research. So treat it like a job. I feel, yeah, I think that's a great way of trying to frame what I'm saying.
Thank you, Ralph. So very quickly, what's next for you? What are your plans now that you're graduating?
I'd like to continue my education in some way, shape, or form. I found myself interested enough in this research project to look at consider a PhD, which is what I'm looking at. But what I'm currently working on is just working more, because I actually did work less to work on these two classes, and so I'm basically like kind of just re-engaging like work, and I'm trying to make the work I want to do as related to my interests in this class. So I am, I am lining up like some tutoring jobs, but I'm also looking at like other positions within like education. I guess what I want to say, like these educational delivery companies, that create curriculum materials and things like that. I'm hoping that what I've done here is enough to show my interest in the topic, but also that they see that, having completed a thesis project, that, I have the right tools for whatever responsibilities they're looking to throw at someone.
Well, thank you so much, Ralph. Thank you for sharing your work with us. Thank you for all your investment in this project. Thank you for your commitment in terms of everything you did as far as participation in the program. You were a peer mentor for us. You attended so many events and you asked amazing questions during Day in the Lives. And it's just been a pleasure to watch your growth as a thinker and as a researcher. I had you in 3 classes, 3 semesters in a row, so I'm really going to miss you because we had great conversations during office hours. So Ralph, for those of you who are in 698, Ralph did things in a way that really showcased just the brilliance of how the capstone is designed. Dr. Marquez Lewis every summer puts a lot of thought into revising the capstone, and there's so much thought that goes into the process of putting things together and of making sure that assignments are well aligned and of making sure that we have appropriate support for students in terms of tutoring, in terms of everything else. If you could see the amount of work that goes on behind the scenes, you would have you have a different understanding than you currently do of the capstone. But Ralph, you made use of all the resources. You did so much, and conversations were so thought-provoking, so wonderful with you over the past 2 years. So congratulations on your fantastic work, and thank you for sharing your work with a wider audience.
I just thought of something too for the 698, 699 students. The book is actually super good and helpful. When I didn't know how to write a particular section, I kind of reread the book, and it really does actually help you think about how you should style your writing. I'm sorry, I don't know if we're supposed to cut off soon, but I will say, like, not everyone is used to academic writing. I wasn't particularly, I've actually done a lot of types of writing throughout my career, but it's been like this sort of academic writing. It took me a while to kind of get there, and I feel like the book really does help you how to think about your writing and how to style your just how to style things. So I would definitely, if you haven't been, check out the book, do, because it's actually, I've actually thought throughout the whole curriculum, like the books that we got for these various courses, really good tools. So yeah, that's it. Definitely, like, like I said, if you get stuck on any section, just look to that book for pointers, and you'll probably find something that could be helpful.
Right. Thank you. And I agree, the book is absolutely useful. And very often your capstone advisor will put pages to look at specifically
Yeah,
for
and
the
it's
book.
something because you're so busy researching that you can overlook it. You know, like you're so, because the research stuff takes up so much time, like you may forget about it, but don't forget about it. It's actually a good resource. Yeah.
I 100% agree. So thank you so much to our SPS community for attending this presentation. Thank you, students. Thank you to the faculty. Thank you to SPS staff. We had so many people from our community who came throughout the day. And I especially want to thank the presenters on behalf of Dr. Marquez Lewis and Nakia Isaac and myself. You have made this a very interesting school year. So thank you so much. And we want to wish you a very happy holiday season and end of the semester.